combination when two or more resistors are connected end-to-end consecutively. They are said to be connected in series combination. The combined resistance of any number of resistances connected in series is equal to the sum of the individual resistances. There is a single path available for current to flow, so same current flows through each resistor, while the potential difference across each resistor is different depends upon its value. This type of combination is used for voltage division. R equals R1 plus R2 plus R3. And so on. The resultant resistance is more than either of the individual resistances. 2. Parallel combination when two or more resistances are connected between the same 2 points, they are said to be connected in parallel combination. The reciprocal of the combined resistance of a number of resistances connected in parallel is equal to the sum of the reciprocals of all the individual resistances. The reciprocal of equivalent resistance is equal to the sum of the reciprocal of individual resistances. The equivalent resistance is smaller than the smallest individual resistance of the resistor in the circuit. 1/R equals 1/R1 plus 1/R2 plus. The resultant resistance is less than either of the individual resistances. Characteristics of the parallel combination of resistors are given below. For a combination of resistors in parallel, the potential difference across each resistor is the same. In a parallel combination of resistors, the amount of current flowing through each resistor is different. The sum of the currents flowing through the resistors, nevertheless, is equal to the total amount of current flowing through the circuit. This type of combination of resistors is used for current division. We will be demonstrating a circuit with 3 resistors connected in series. We will be using a voltmeter and an ammeter to measure the voltage and current through the circuit, as well as a power supply to provide the energy for the circuit. First, we will connect the 3 resistors in series by attaching one end of the first resistor to the positive terminal of the power supply and the other end to one end of the second resistor. We will then attach the other end of the second resistor to one end of the third resistor, and the other end of the third resistor to the negative terminal of the power supply. Next, we will connect the voltmeter in parallel with each resistor to measure the voltage across each resistor. We will also connect the ammeter in series with the resistors to measure the current flowing through the circuit. When we turn on the power supply, we will observe the readings on the voltmeter and ammeter. We will also attach a bulb in series with the resistors and observe the brightness of the bulb. Since the resistors are connected in series, the voltage will be divided between the 3 resistors, and the current will be the same through each resistor. As a result, the bulb will be dimmer compared to when it was connected directly to the power supply. demonstration. Now, we will demonstrate a circuit with 3 resistors connected in parallel. We will again be using a voltmeter and an ammeter to measure the voltage and current through the circuit, as well as a power supply to provide the energy for the circuit. To connect the resistors in parallel, we will attach one end of each resistor to the positive terminal of the power supply and the other end to the negative terminal of the power supply. Next, we will connect the voltmeter in parallel with one resistor to measure the voltage across it, and the ammeter in series with one resistor to measure the current flowing through it. We will repeat this for each resistor. When we turn on the power supply, we will observe the readings on the voltmeter and ammeter. We will also attach a bulb in parallel with the resistors and observe the brightness of the bulb. Since the resistors are connected in parallel, the voltage across each resistor will be the same, but the current will be divided between the 3 resistors. As a result, the bulb will be brighter compared to when it was connected in series with the resistors.